Hi, in this video I will be talking about implementation of autoencoder for CIFAR-10 dataset using TensorFlow and Keras. So let me quickly introduce what is autoencoder. Autoencoders are a specific type of feed-forward neural networks where the input is same as the output. They compress the input into a lower dimensional code and then reconstructs the output from this representation. The code is a compact summary or a compression of the input, and also it's called a compressed representation. So autoencoder basically contains three blocks. The first block is a encoder block, and the last block is a decoder block, and in between we have something called a bottleneck block. So encoder basically encodes the input image into a smaller dimension, or it reduces the dimension and compress the image, and that image is stored as a latent space representation, and the same latent space will be again decoded back so that the original image would be reconstructed. So you may be wondering why we need to encode and decode it back to the original image. So the whole idea here is when we encode, we remove the unnecessary details of the image so that we can reduce the space. At the same time, we can also learn the features of that particular image so that it can be used later. So in order to implement autoencoder, basically there are three components. So the first component is encoder, the second component is the decoder, which I have just explained, and there is something called a loss function. So the purpose of the loss function is to compare the difference between the encoded image and the decoded image. So which means that I have an original image, I have encoded, and then I have a decoder which will decode my encoded image, and an image will be produced. Now I need to compare between my original image and my decoded image. So to make that comparison, the loss function will be used. So the pipeline is pretty simple. As I have been talking about, we have encoder and the decoder. So the encoder functionality is to gradually reduce the dimensions of the image so that it will be downscaled and stored in as minimal as possible, while preserving the maximum details of the image. So that's why we use the max pooling along with the convolutional 2D. So max pooling will basically downsize from a higher dimension, which is 32 by 32 to 16 by 16. So in this video we are implementing autoencoder for CIFAR-10. So CIFAR-10 uh, is a data set where every image is of size 32 by 32, and we reduce 32 by 32 to 4 by 4, and we store it as a compressed image, and then we use decoder to reproduce the original image. And since we have to upgrade, or we have to upscale the image from lower dimension to higher dimension, so we will be using convolutional 2D along with upscale. Now let's go back. Now let's go to implementation of CIFAR-10. So I have a colab notebook here. I will be sharing the implementation in the description. So please, you can feel free to download and run it by your own. So let's go step by step. In the first step, so we import the required packages. So you can see that I have used Keras as well as the TensorFlow here, and the optimizer I'm using here is called Adam optimizer, and then I have imported NumPy, Pandas, and Matplotlib for the various utility functions. So the first thing that I have done here is I have written a simple utility function which takes the original image as well as the decoded image, which I am going to do later, and up to 10 images, and both images will be original as well as decoded. Both images will be shown in this using this utility function. And yeah, this is how you need to load a CIFAR-10 dataset. And if you just write this statement, so it will automatically download the dataset into your memory. And then we need to let's first see what is the dimensions of the CIFAR-10. As I mentioned, so CIFAR-10 contains total 60,000 images, and where each image is of size 32 by 32, and each image has 3 channels RGB, and we are considering the image size which is exactly equal to CIFAR-10 image, and the number of epochs are going to be 50, and the batch size is 50. And this is how we build autoencoder pipeline. So we first do the we first normalize the data and then build the pipeline. So we are just converting the data to float and then normalize the data by dividing by 255. You can just match the code with the pipeline that I have shown in the PowerPoint presentation. So you can see that I have 1, 2, 3, 4 convolutional layers with 2 max pool, 3 max pooling layers in order to downgrade from 32 by 32 to 4 by 4. So and then I have again I have a convolutional layer along with upsampling layers, so that the encoded image will be decoded back in this particular line. So my decoded variable contains the decoded image of the encoded image, right? So this will build the model, and then this will compile the model with Adam as an optimizer and MSE as my loss function, and the metrics that I will be using are accuracy. Yeah, CIE.summary will show you the summary how your model is going to look like. So you can see the how your model is going to look like. So it starts with 32 by 32 and 3 layers, and then it gradually downsize the image and it goes up to like 4 by 4. So up to this, so this is an encoding part, and from here it starts decoding. So it will decode and it will upscale from 8 to 16 and then up to 32, right? So this is just a summary. We have not yet trained our model, right? So we just printing some details here, and then this is the place where we are training our model. CIE.fit will train our model, to train our model we use 100 epochs with the 50 batch size, and you can see how this particular training goes on up to 100 epochs. So at every epoch you can see the loss value, accuracy, validation loss, and validation accuracy. So the two things that we worried about here are the loss function and the accuracy. So intuitively, so loss has to be gradually decreased and accuracy has to be gradually increased. That's what we expect. So after 100 epochs, so we can write a function using matplotlib to visualize our validation loss and accuracy. So we see that the validation loss is slowly going down while the accuracy is slowly going up, right? So and then we use, since we have divided our data into training and test, now we use CIE.predict to predict our test data. So predict basically reconstruct the image, right? So and then we display the encoded image and the decoded image, and we will see how our original image look like and how our autoencoder were able to decode the image and visualize. So you can see that the first line is the original image and the second line is the decoded image. Of course, it may not be exactly as it is visible in the original image, but still using the autoencoder, so we were able to downsize to 4 by 4, and then we were able to reconstruct with a minimal with a maximal representation. So this is how the autoencoder works. So thank you for watching this video. So if you like this video, please subscribe and keep watching my videos. Thank you.